a circuit problem here that shows a 12-volt battery connected to a bunch of resistors in this circuit, and we're given the value for each of these resistors. And we want to figure out how much current is the battery putting into the circuit, and we want to figure out the current across each of these resistors. So we'll apply two rules here. We'll use Kirchhoff's current law, we'll use Kirchhoff's voltage law. So we'll start with current law. We know that at a junction, the current splits between these two, and eventually when they meet again, they add back up to the total current. So basically, the total current remains constant across this split. If we were to add these two splits together, they'd equal this current. And how we're going to use that here was, well, for R1, we can just say there's a current of I1 passing through this, but then the current that is going this way will just be I minus I1. And in this way, we can just write the currents across each of the other resistors in terms of one another. So let me write that a little better. That's I1. We'll come down to this junction. It splits again. We'll say the current going this way is I3, and the current going this way will now be I1 minus I3. And so basically we have all of the currents across these resistors, or we've made the equivalent current for them. So we know the current for this, we know the current for this is I1, this is I3, this is going to be I1 minus I3. This one, the current coming down will be I minus I1, and this current adds to it, so it will become I minus I1 plus I3. That'll be current going through the R5 resistor. So once we've gotten that out of the way, we'll focus on Kirchhoff's voltage law, which states that the sum of the voltages used by, or the voltage drops across each of the currents in a loop, will eventually come to 0. And since we have 3 unknown currents, we have I, I1, and I3, we'll need 3 loops. We'll write out the voltage drops across 3 of these loops. So in this case, I'll use this left side loop right here. I'll use the outer loop that's going all the way around, and I'll use this loop that's coming around the top and then goes through here and comes down. Basically, I just use the top loop here in this situation. Okay, so let's get started on the left side loop right here. So we have 14 volts, and over the loop we hit R1, and the voltage drop across R1, V equals IR. So the voltage drop across R1 will be I1 times R1, which is 1 ohm. So we can just substitute 1 for R1 there. Then we'll hit R4. The current going through that is I1 minus I3. And our resistor 4 is 2 ohms, so we'll write 2 for that. And that will all come out to 0. And then I'll do the same for the outer loop. Outer loop, 14 volts. We hit resistor 2, which is 2 volts, so it'll be minus 2 times the current going through it, which is I minus I1. And then we'll hit resistor 5, which is 1 volt times I minus I1 plus I3 equals 0. And we will get, for our top loop, there's an important concept you have to keep track of here. You need to keep track of which way your current is going. So I'll start out normally. I'll start out with 14 volts minus 2 times I minus I1, because it goes down through here, and it goes up this branch. But the thing is, when you're going against the current up a resistor, it's essentially, you can say that it's like negative current, or that the voltage will be added for this resistor if we're going up this way. So we'll say plus R3 is 1, and then the current going through is I3. So we'll actually add 1 times I3 to this voltage. And then after that, it's pretty much normal because the current is going down this way and we're going with the current. And so we'll say minus R4 is 2 times I1 minus I3 equals 0. So those are the 3 equations that we'll use to solve for each of the currents, I1, and I3. And I'm going to go ahead and simplify this real quick. Alright, so I've gone ahead and simplified those systems equations, so we're left with these 3 equations, and I would highly recommend learning matrices when it comes to solving these types of circuits, because it makes solving for all the i's so much easier. It's not that hard to learn, it's just you need to know your matrices and learn Gauss-Jordan method, and that's pretty much it. You could substitute, but that would take a long while. So I'm gonna just go ahead and use Gauss-Jordan. I'm just gonna put this into matrix form. First, I'm gonna simplify it a little further, so it's a little more clear to y'all. So we can just bring all the currents on one side and leave the voltage on the other. So we'll have 14 equals 3I1 plus 2I3. For this loop, it equals 3I minus 3I1 plus I3. And in this case, it equals 2I plus 3I3. Okay, and I'm just going to go ahead and put this into matrix form real quick. So I went ahead and put it into matrix form. I made a minor mistake right here. This will become negative 3I3. And you really have to watch out in this step. This is the step where I personally make a lot of mistakes because it's so hard to keep track of like everything from this to simplifying it to putting it into this form. It's just gets hard to keep track of all the little i's and everything. But this should be the matrix, and I'm going to make an augmented matrix because this is where we'll get the values of our I from. And then I'll just go ahead and apply Gauss-Jordan real quick. And this is the answer I got after solving this matrix. So we got, for the total current, we got 10. For the I1, which is here, it's 6. I3, we got 2 amps. And now that we know these, we can literally just find all of the currents across each resistor. So the total current is equal to 10. The current across the resistor 1, I1, is equal to 6. Current across resistor 2, which is I1 I minus I1, we'll call it I2, is equal to 4. Yeah. And current across resistor 3 is equal to 2. I'll write the amperes in front of them. Okay. The current across resistor 4 is I1 minus I3. I'll underline the ones we already know. So I1 minus I3, it was 4 amps, and the current across resistor 5 will be I minus I1 plus I3. So 10 minus 6 plus 2 should be 6 amps, I believe. Yeah. Okay. And there you have it. That should be your final answer right there.